Hello guys, so today's topic is empirical formula and molecular formula. Okay, so in this topic we are going to discuss what is the difference between empirical formula and molecular formula, and then we'll solve the questions based on empirical and molecular formula relations. Okay, so let us start with the empirical formula. Now the empirical formula means what? The empirical formula is nothing but what? Simplest whole number ratio of atoms in a compound. Okay, so empirical formula represent what? The simplest simplified formula of a compound. Simplified formula of compound is known as an empirical formula. Okay, for example, in hydrogen peroxide, H2O2. So there are total two hydrogen atoms. Okay, so let us take the ratio of atoms. Hydrogen is to oxygen, the ratio of number of atoms, not a molar mass or not a number of moles. So we are taking the ratio of number of atoms. Okay. So how many atoms are there? Two hydrogen atoms and two oxygen atoms. Two hydrogen and two oxygen atoms. Okay. Now let us convert this into simplified form. Okay. So let us convert this into simplified form. Divide by 2. So in simplified form, the ratio of the number of hydrogen to number of oxygen is 1 is to 1. Okay, so in simplified form, number of hydrogen atom is 1 and number of oxygen atom is equal to 1. Okay, so the 1 H1 oxygen 1 is nothing but what? Empirical formula for hydrogen peroxide. Okay, similarly, we can calculate empirical formula for any type of compound, for any compound. Let us take another example. Another example is benzene. Molecular formula of benzene is C6H6. Okay. Now in benzene we know that there are total 6 carbon atoms and 6 hydrogen atoms. So let us take the ratio of the carbon is to hydrogen. So how many carbon atoms are there? Total 6 carbon atoms and total 6 hydrogen atoms are there in single molecule of hydrogen, single molecule of benzene. Okay. Now let us simplify the number of atoms ratio. So in simplified form, the number of ratio is, let us divide by 6. Okay. So ratio of carbon is to hydrogen is, how many carbon atoms are there? Now in simplified form. So ratio is equal to 1 is to 1. So formula is C1H1. It is also written as CH. So CH is the empirical formula for benzene. Okay. Now let us take another example, glucose. If a formula for glucose is C6H12 oxygen 6. Okay, the fructose and glucose both have same formula. Now, how many carbon atoms are there? Take a ratio. Carbon is to hydrogen is to oxygen. How many carbon atoms are there total? 6 carbon atoms. Number of hydrogen atoms is 12 and number of oxygen atoms is equal to 6. Okay. Now here, these numbers are divisible by 6. So let us simplify this numbers. So in simplified form, the ratio of carbon is to hydrogen is to oxygen is equal to 1 is to 2 is to 1, right? So empirical formula can be written as C1H2 and oxygen 1. Okay, or this is also can be written as CH2 oxygen, CH2 oxygen. Okay, now what is a relation? How empirical formula is related to its molecular formula. Okay, so let us take example of hydrogen peroxide only. So we can easily calculate or easily determine the relation between empirical formula of hydrogen peroxide and its molecular formula. Okay, so let us take example of hydrogen peroxide. Now in hydrogen peroxide, H2O2, this is a molecular formula for hydrogen peroxide and its empirical formula is HO. HO, its empirical formula. Okay. Now, if we multiply this HO by 2, then we will get molecular formula, right? So, N here is 2. 2 is nothing but what? So, 2 is equal to. So, 2 is equal to what? It is molecular formula weight of hydrogen peroxide divided by empirical formula weight of hydrogen peroxide. Empirical formula weight of hydrogen peroxide, right? So what is the molecular formula weight for hydrogen peroxide? 34. Okay, that is the molecular mass of for hydrogen peroxide is 34. And if you take the empirical formula weight, that is 1H and oxygen weight is equal to 17. It is equal to 2, right? Now let us take another example for benzene. So benzene molecular formula is C6H6. Its empirical formula is CH. If you multiply CH by 6, then you will get its molecular formula, right? So 6 is equal to what? 6 is equal to molecular formula weight of benzene, molecular weight formula weight of benzene divided by empirical formula weight of benzene, right? So what is the molecular formula weight of benzene? It is equal to 78 and its empirical formula weight, that is CH, carbon 12 and one hydrogen atom, 12 plus 1, 13. Okay, so this is equal to, so ratio of molecular formula weight to the empirical formula weight is equal to 6, right? Now similarly for glucose, C6H12 oxygen 6, which is equal to, now empirical formula for glucose is CH2 oxygen. If you multiply the empirical formula of glucose by 6, then we'll get its a molecular formula, right? So here the value in empirical formula, if you multiply empirical formula of hydrogen peroxide by 2, then we'll get its molecular formula. If you multiply the empirical formula benzene by 6, then you'll get its molecular formula, right? So these numbers are nothing but what? So these numbers, so let us denote these 266 by n, small n. So small n is nothing but what? Small n is equal to molecular formula weight of the substance divided by empirical formula weight. Molecular formula weight of a substance divided by empirical formula weight. Okay. And molecular formula of a compound is equal to empirical formula empirical formula into n. Empirical formula into n. Okay, so these are the two very important formulas which are related with empirical formula and molecular formula. Okay, now let us solve some examples. Let us find the value of n for few more compounds. Let us take another example. Okay, so next example is water. Water molecular formula. Let us find the empirical formula for water and let us find the value of n. Okay. Now in water may the ratio hydrogen is to oxygen ratio is hydrogen is to oxygen ratio is 2 is to 1. Okay. So in simplified form also the ratio is 2 is to 1. So empirical formula for water is same as its molecular formula. So value of n is equal to 1. Okay. So second example is ethene. C2H4. C2H4. Now ratio of carbon is to hydrogen in ethene. Carbon number of carbon is 2 and number of hydrogen atoms is equal to 4. Right? So let us convert this into simplified form. So number of carbon atoms is equal to how many carbon atoms are there? There are 2 carbon atoms and 4 hydrogen atoms, right? So let us convert it into simplified form. Let us divide these numbers by 2. Both numbers are divisible by 2. So in simplified form, the ratio of carbon is to hydrogen is 1 is to 2, right? Yeah. So its molecular formula is what? Carbon 1, hydrogen 2, right? Now, what is the relation between empirical formula of this ethene with its molecular formula? Okay, so if we multiply this empirical formula by 2, then we will get its molecular formula, right? Okay, so next example is ethane C3H8. Okay, now here carbon is to hydrogen ratio is equal to 3 is to 8. Okay, so this is the carbon hydrogens are present in simplified form in ethane. So Further simplified form is not possible. So its empirical formula is same as its molecular formula C3H8. So if the empirical formula is same as the molecular formula, then the value of N is always equal to 1. Okay. So this is all about empirical and molecular formula relation. Now let us solve some questions based on this empirical and molecular formula. Okay. 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 So first question is the empirical formula of a compound is CH2O and its molecular mass is 120. The molecular formula of a compound is, right? The question, the empirical formula of a compound is given to us and its molecular mass is also given to us. Okay. Now how to calculate molecular formula. Okay, so to calculate molecular formula, what is required? Required is the value of n. So if you know the value of n, then it is easy to find its molecular formula, right? Okay, so empirical formula is given. So empirical formula is CH2O. Let us calculate first its empirical formula weight. So empirical formula weight is equal to empirical formula weight is equal to carbon 12, hydrogen 2 into 1 plus oxygen 16. Okay, so which is equal to 30. So empirical formula weight for CH2O is equal to 30. Now let us find N. We know the formula. N is equal to molecular formula weight divided by empirical formula weight. Now, if we take the ratio, the molecular formula weight is given to us is equal to 120 and empirical formula weight is 30. Okay, so ratio of molecular formula weight to the empirical formula weight for given molecule, given compound is equal to R at 4, right? Okay, so now let us apply the formula. Molecular formula is equal to empirical formula into N. So empirical formula is given to us. Let us substitute the value. CH2O into 4. Now 4 into 1. So carbon 4, hydrogen 8 and oxygen 4. Okay. C4H8 oxygen 4. Fourth option is correct. Okay. Now second question. In second question, in a hydrocarbon, the ratio of mass of hydrogen to the carbon is 1 is to 3. The empirical formula for hydrocarbon, so mass ratio is given to us. Empirical formula is, so mass ratio, weight of hydrogen is to weight of carbon, this ratio is given 1 is to 3. Now to write empirical formula or molecular formula, what is required? A mole ratio is needed, right? Okay. So let us find mole ratio. Mole ratio of hydrogen to the mole ratio of carbon. Now we know the formula of moles. Moles is equal to weight of hydrogen, right? And divided by molar mass, or you can take atomic mass here for hydrogen, is to weight of carbon divided by atomic mass of carbon, right? Now, so weight ratio is given to us, right? Weight ratio is given to us. So this formula can be written as, can write this formula like this: weight of hydrogen divided by weight of carbon is to atomic mass of carbon divided by atomic mass of hydrogen. Now this weight ratio is given to us 1 by 3. Now atomic mass of carbon 12 and atomic mass of hydrogen we know it is equal to 1. Okay. So number of mole ratio is equal to 4. Okay. So means the number of hydrogen atom is equal to 4. So number of hydrogen atom is equal to 4 and number of carbon atom is equal to 1. 4 is to 1, right? So 4 is to 1, H4 carbon 1, that is CH4. First option is correct. Okay. Yeah. Now let us move to the next question. Question number 3. Okay. So in question number 3, the empirical formula of a compound containing hydrogen, carbon, oxygen, and nitrogen in the mass ratio is 1 is to 3 is to 4 is to 7 is. Okay. Now, so in question, the mass ratio is given to us. They are asking to calculate what? They are asking to calculate empirical formula. Now, so empirical formula is nothing but what? It represents simplified ratio of atoms present in molecules, right? But the atoms are present in the simplified forms of their number of moles. Okay, so find the mole ratio of atoms in simplified forms. Okay, so mass ratio is given, but we need which ratio? We need the moles ratio. So let us take mole ratio. Mole ratio of, let us start with hydrogen. Hydrogen is to carbon, it's to oxygen, is to nitrogen. Okay, so this mole ratio is needed. Now, moles is nothing but what? Weight by atomic weight ratio. Here also weight of carbon divided by its atomic weight, weight of oxygen divided by its atomic weight is to weight of nitrogen divided by its atomic weight of nitrogen. Okay. Now, so weight ratio is given to us, right? It is 1 is to 3 is to 4 is to 7. The weight ratio is given. So 1, let us take 1. Mass of hydrogen, atomic mass we know 1. Weight ratio for carbon is 3. And atomic mass for carbon is 12. Okay, weight ratio for oxygen is 4 is given, atomic mass for oxygen is 16, nitrogen 7 atomic weight, atomic weight is given to a 7 weight ratio, and atomic mass carbon is 14. Okay, so let us convert this simplified form. 1 is to 1 by 4 is to 1 by 4 is to 1 by 2. Okay, so let us convert into simplified form, simple whole number ratio. Let us multiply by 2. If you multiply it by 2, the equation become, sorry, instead of 2, let us multiply by 4. So equation become 4 is to 1 is to 1 is to 2. So this is a mole ratio of the atoms, hydrogen, carbon, oxygen, and nitrogen in simplified form, right? So which one is the correct option? C4, so H4, sorry, H4 means H4, and then carbon 1, oxygen 1, and nitrogen is equal to 2. Okay, so this third option is correct. Now, next question is question number 4. The compound contain equal masses of elements P, Q, and R. If the atomic masses of P, Q, and R are 10, 20, and 40 respectively, then empirical formula of a compound is. Okay. So here, what is given to us? Equal masses of the elements P, Q, and R given to us. Okay. Now here also take a mole ratio, number of moles of P atoms is to number of moles of Q atom is to number of moles of R. Okay, mole ratio. Now number of moles is equal to weight divided by atomic weight of P is to weight of Q divided by atomic weight of Q is to weight of R divided by atomic weight of R. Okay. Now weight ratio is given to us. Weight ratio, it is mentioned that equal masses, they have equal masses, right? So equal masses, let us take x by 10, atomic mass given to us, x by 20 is to x by 40. Okay, so atomic masses are given. Now let us convert this into simplified form. Let us multiply by 40 by x. Okay, so if you multiply by 40 by x, okay, then in simplified form we'll get 4 is to 2 is to 1. Okay, 4 is to 2 is to 1. So its empirical formula is what? P item, number of P items is equal to 4, number of Q items is 2, and number of R items 1. Okay, so first option is correct. Okay, so now next question is question number 5. In question number 5, the compound has carbon, hydrogen, oxygen in 4 is to 4 is to 1 atomic ratio, right? If the moles in 1 gram of compound is 1.47 into 10 to the power minus 2, then molecular formula of compound will be, right? Now, here in this question, the carbon, hydrogen, and oxygen, the atomic ratio is given to us, right? So atomic ratio is given to us. So carbon is 4, hydrogen also 4, and oxygen 1. So atomic ratio is this is nothing but what empirical formula. So let us first calculate empirical formula weight. Empirical formula weight. So this is empirical formula. Empirical formula is given to us. Now empirical formula weight is equal to, it is equal to 12 into 4. 4 hydrogen atoms are there. 4 carbon atoms are there. Plus hydrogen atomic mass is 1. 1 into 4 plus 16 is atomic mass of oxygen into 1. Okay. So which is equal to 48 plus 4, 52. 52 plus 16, which is equal to 68. Okay. So gram formula, not a gram formula weight, this is the empirical formula weight. The empirical formula weight of C4H4 oxygen 1 is equal to 68, right? Yeah. Now, what is required? Molecular formula weight is needed. Now, how to calculate molecular formula weight? Now, in question, the question is mentioned that 1 gram of the compound, mole is equal to 1.48 into 10 to the power minus 2, right? So we know the number of moles formula, number of moles of the substance. Number of moles of a compound is equal to number of moles of compound. What is the formula? Formula is equal to given weight divided by molar mass. This is the formula. Okay, molar mass. Now, number of moles is given to us. So, if we rearrange the formula, then we'll get the molar mass. Molar mass is equal to given weight divided by number of moles of compound. Okay, now let us substitute the values. Given weight is equal to, so 1 gram is given to us divided by number of moles is equal to 1.47 into 10 to the power minus 2, right? So let us calculate the molar mass. Molar mass is equal to, so molar mass is equal to 1 into 10 to the power minus 2. Now 10 to the power minus 2 taken to numerator, it become 10 to the power 2 divided by 1.47. 1.47, right? Yeah. So which is equal to 100 divided by 1.47. 1.47, which is equal to. So let us calculate this value. 10,000 divided by 147. Okay. So which is equal to, let us calculate this. Okay, so here we'll get approximately 68 molar mass 68. Okay, now let us find n value. N is equal to molecular formula weight divided by empirical formula weight. So molecular formula weight is equal to 68, empirical formula weight is equal to 68. So n value is equal to, so if n value is equal to 1, then we know that it's if the value of n is equal to 1, so we know that its empirical formula is same as molecular formula. So this empirical formula is same as molecular formula. So both option is correct, right? Yeah. So now next question is the empirical question number 6. The empirical formula of gaseous compound is CH2O and the density of a compound is 2.5 gram per liter at NTP. Okay, that is normal temperature pressure. They are asking to calculate the molecular formula, right? Okay, so now how to calculate molecular formula? How to calculate molecular formula? The density is given to us. So what is the needed requirement is, what is the requirement? Requirement is molecular formula weight is required. So now how to calculate molecular formula weight, right? So see, density is given. So let us use the formula of density. Density we know density is equal to mass by volume. So here mass is weight and mass by volume. Okay. Now density is given 2.5 gram per liter is equal to NTP. We know at NTP the volume is equal to 22.4 liter. 22.4 liter per mole. Liter per mole. Okay. So mass is equal to, it is equal to 2.5 into multiply 2.5 gram per liter into multiply by 22.4 liter per mole. 22.4 liter per, okay, so which is equal to equal to 22.4 into 2.5. Okay, so 20 into 400, 10, 50 into 10, 66, 25 into 2, 50, 56, 56 gram per mole. Okay, so molar mass of the compound is equal to 56. Now, empirical formula is given to us. So use empirical formula. Empirical formula is given. It is equal to NaCH2. Now, empirical formula weight we can calculate. Empirical formula weight is equal to carbon. So how many carbon atoms? What is the weight of carbon? 12. 12 plus 2 into 1, right? Uh, 1 is the atomic weight of hydrogen. So empirical formula weight is equal to 14. Okay, now let us find the value when n is equal to, n is nothing but what? N is equal to molecular formula weight divided by empirical formula weight. So is equal to, what is the molecular formula? So molecular formula weight is equal to 56 and empirical formula weight is equal to 14. Okay, so which is equal to 14 fours are 56. Okay, so value of n is equal to 4. Now the molecular formula is equal to empirical formula into multiply by n. So empirical formula is CH2 into multiply by 4. So molecular formula compounds become C4H8, right? C4H8. Good. Now next question, question number 7. Empirical formula compound is CH2 CH2O and its vapor density is 30. The molecular formula of a compound is, right? Now we know the relation between vapor density and molecular formula. Okay, so molecular formula is or molar mass is equal to, we know the relation between molar mass and its vapor density, right? Molar mass is equal to what? How it is related to vapor density? Molar mass is equal to vapor density into multiply by 2. Now, molar mass, we don't know the molar mass, but the vapor density is given to us, right? So we can use the vapor density. Vapor density 30 into 2, so molar mass is equal to 60, right? Now, empirical formula weight is given to us. Empirical formula weight, we can calculate from a formula. Empirical formula is given, right? Yeah. So empirical formula weight is CH2O. This is the empirical formula. So carbon 12 plus 2 into hydrogen 1 plus oxygen 16. Okay. Now, so 12 plus 16 plus 2 becomes equal to 30, right? Now find the value of n is equal to molecular formula weight divided by empirical formula weight. Value of n is equal to 2. So molecular formula of compound is empirical formula into multiply by 2. So molecular formula given compound is equal to carbon 2, hydrogen 4, oxygen 2, right? C2H4 oxygen 2. Now next question, this last question, question number 8. The compound contains 52.70% of carbon, 13.04% of hydrogen, and remaining oxygen by weight. The empirical formula of compound is. Okay, so in this question, percentage are given to us. Okay, now if the percentage are given, then let us consider total percentage. Total percentage, first check the percentage, the sum of percentage of the constituent particles is 100 or not. If it is not, then the make it 100%, that is remaining percentage that belongs to oxygen atom, right? So sum of the percentage of the constituent particles is always equal to 100%. Okay, so percentage of carbon plus percentage of hydrogen plus percentage of oxygen is equal to 100. Okay, now 52.70% of carbon is given plus 13.04% of hydrogen plus oxygen percentage is equal to 100. Okay, so this is equal to 17 plus 0.4, 21, 5, 65.21%, plus percentage of oxygen is equal to 100. So what are the percentage of oxygen? Percentage of oxygen is equal to 100 minus 65.21 percentage. Okay. So which is equal to 100 minus 65.21 percentage, which is equal to 34.79 percentage. 34.79%. Okay, so these are the percentage of what? Percentage of, these are the percentage of oxygen, right? Okay. Now let us convert the percentage into mole ratio. Now how to find a mole ratio? The percentage of carbon. So let us find the mole ratio. Carbon is to hydrogen is to oxygen. Okay. Now percentage 52.17 percentage of carbon is given to us. Let us divide this percentage by atomic mass 12. Percentage of hydrogen is 13.04. Let us divide this 13.04 by its atomic weight 1. Oxygen percentage 34.79 divided by mass 16, right? Okay. Now let us find the values. Number of carbon atom. So let us find the carbon atom simplified form. Okay. They go 12, 4s are 48, 48, 4, 1.3, 4.3, okay, 41, 47, so 4.34, okay, approximately 4.34 is to hydrogen percentage 13.04 only, and oxygen 16 twos are 32, 2 7 16 ones are 16, then 119, then 16 sevens are 112. Okay, so let us convert this into simplified form. Let us divide by smallest number here. Smallest number is 2.17. 13.04 divided by 2.17. 2.17 and 2.17 divided by 2.17. Okay, so in simplified form, this ratio is 2 is to, ये बन जाएगा 6 is to 1. Okay, so 2 is to 6 is to 1, right? So how many carbon atoms are there? So number of carbon atoms is equal to 2, number of hydrogen 6, and number of oxygen atom is equal to 1. So C2H6 oxygen 1. Okay, yeah. Thank you so much, guys.